Hello friends, today I will be discussing about t-test. Basically, I will be discussing about how to calculate t-values, t-ratio from for a given problem. So t-test is one of the widely used tests for any type of research data collected in the field of social sciences, psychology, education, philosophy, sociology. Whenever some quantitative data you are getting from population and sample, for that you are using t-test, and it is quite widely used. So how to calculate t-test, how to get the value of t-ratio, that we will try to understand. So if you see the basic background of t-test, which is also called as students t-test. T-test is a statistical test used to compare the means of two groups developed by William Shelley Gosset under the pseudonym student. That's why it is also called student t-test. It is used to determine if there is a significant difference between two data sets. So whenever two data set is there, suppose you want to compare the mean values of boys and girls. Whenever you try to compare the mean values of achievement for government school teachers, government school students and private school students, so in that type of cases, whenever the data is collected in an interval scale or ratio scale, so in that cases you are using students t-test. So it is used to determine if there is a significant difference between two data sets. So whenever two data set is there, suppose you want to compare that mean difference of boys and mean of the boys and girls in achievement is significantly different or not, or suppose the um, attitude towards science in government school students and in the private school students, if you want to compare, then you will use t-test. So it is used when population variance is unknown as sample size is small. So it is used in both cases. If the sample size is small, basically it is used for it is used when the sample size is small. When the large sample is there, then you are using z-test. But because t-test is based on a small sample size, so many a times when the large sample is also there, you try to use t-test because it will reduce the error, because those cases whenever it is the test which is based on small sample data set, so that test is quite stricter than the large data set. So many times you are using it for large sample size also. So when n is greater than 30 also, you are using t-test also, but basically it is meant for small sample size. The t-test is used to compare sample means when the population variance is unknown, especially for small samples. When sample variance is unknown, then you are using it. That is the basically it is meant for that. But it can be used for large sample size, and I told you because it is a stricter. So if it is large sample is also, the error chances are less, but still if you are using t-test, the chances of committing error reduces more further. That's why in large sample also you are using student t-test. Now there are different types of t-test. First one is one sample t-test, dependent sample t-test, and third one is paired sample t-test. We will try to understand these all three types, taking one at a time, and there I will give you different examples. What you understand by one sample t-test, what is the meaning of independent sample t-test, and what is the meaning of paired sample t-test. So let us take the example of one sample t-test. So one sample t-test try to compare whether the sample mean, whether the data set from which you have collected the data set, whatever value it is giving, is it equal to some predetermined value. Many times it is the population mean. Suppose you are saying that the performance of students for 5 years, the average performance of the students in mathematics is 80. Now if in a particular year, if you take a test in mathematics, suppose for 100 students, then how this performance is equal to the trend, the earlier trend, suppose is it equal to 80 or not. So in this type of cases, whenever a sample is compared with a fixed value, that is called as one sample t-test. Again, let us take one example. Suppose a rainfall rainfall in previous 5 years. Suppose the average value is already fixed there, that in Patna this much of rainfall occurs in the month of September. Now if you calculate this, collect data from each day throughout September month, and then you get the uh, rain data, how much centimeter it rained, and then you calculate it, try to compare with the fixed value of whatever is already there for the previous benchmark of 5 years, then it is one sample t-test. Again, you can take one more example. Suppose you are you have got some ISI standards for certain manufacturing device, suppose battery, suppose helmet, or something like that. Now if manufacturing is there in a particular company and you producing 100 units of helmets in a particular hour, then if you try to get the dimensions, suppose the weight of that particular sample, that particular set of helmet, is it equal to the benchmark of prescribed ISI standard? So that these all cases are example of one sample t-test. Now the formula here is t is equal to x mean of the sample, and then what is the benchmark, then standard deviation of that particular sample, and then divided by square root of n, and degrees of freedom is n minus 1. Now try to take one example. A company claims average battery life is 100 hours. So this is the benchmark. This is the benchmark, that battery life of a particular device is 100 hours. Now you take sample, suppose 10 batteries you are taking, and then you just try to get the average battery life, and then you have got the mean as 96. 96 mean you have got. Suppose one battery has got average life is equal to 105, someone has got 98, and then you take the average. So sample, for 10 samples of cells battery, you have got mean as 96 and standard deviation is 4. So at 5% significance level, what is the null hypothesis? Mu equal to 100 or mu is not equal to 100, means whatever average you have got 96 or this one, is it equal to the benchmark 100? So you use this particular formula, you use it, 96 minus 100 divided by 4 square root of 100. So you got this t-test value as minus 3.16, although this minus sign will be not taken care of, only the absolute value without this negative sign, because this is, you can always get the difference, it is 100 minus 96 also you can do. So the t-test value is 3.16. now if you follow the table value at degrees of freedom 9, because it is 10 here and to n minus 1 9, so critical t value is from the table is 2.262. so this value is quite higher than 2.262. so you have to reject the null hypothesis that battery average life is 100 hours, because it is significantly different. T is greater than whatever t value we have got, it is different than the table value. So reject has 0. So what conclusion you can say? The sample mean differs significantly from 100 hours. So you have to see about the manufacturing of that particular battery, and you have to take certain measure. So this is one case of one sample t-test. Let us take some other example. This is one other example for small sample size. Research question: is mean daily screen time different from 20 hours? This is the benchmark. 20 hours is the benchmark. Now you have taken 15 students you have taken, or 15 children you have taken, sample you have taken, and then you try to see the screen time of theirs. Suppose their average mean screen time is coming to 22 hours, and then standard deviation is 3 seconds. So it is also case of two-tail. You are just hypothesizing that there is no difference between the standard value and the sample whatever mean you are getting. Now hypothesis is mu equal to 20. Null hypothesis, you are saying that both are equal, but alternative hypothesis will be it is not equal to 20 hours is not equal. So again you use the same formula. t is equal to x sample mean minus the standard value and divided by standard deviation by square root of n, and you got the value as 2.582. 2.582 you have got. Now again for degrees of freedom 14, because n is 15, df is n minus 1, 14. So seeing the value at 0.05 level, you have got t equal to 0.025 comma 20. 0.025 because it is two-tailed test, both side 0.025 level is there, or 2.5% cases are there. So it is for two-tailed test, the df is the t value is critical value is 2.145. The calculated value is more than 2.145, so we have to reject the null hypothesis. So you can say that no, the alternative hypothesis will be correct. The null hypothesis has to be rejected. So the average daily mean screen time is not equal to 20 hours. So it is different. So the conclusion is at 5% significance, there is evidence the mean differs from 20 hours. So that you have to try to see. Now if the samples, again for the one sample size test, t-test, this if the sample size is n greater than equal to 30, then also you are using the same formula. Now suppose you are manufacturing scales of 100 centimeter and the benchmark is 100 centimeter. Benchmark is 100 centimeter. Now if you take the sample of 100 scales and the mean length of that scale is 102, so suppose some scales are more, some is less. Now if you are trying to, and standard deviation is 10 and alpha you have said 0.05, although you can say that if you are manufacturing a product like scale or this type of devices, the alpha has to be more stricter. Now because you are concerned about the manufacturing of the scale, it is one important device. You cannot manufacture scales of with a millimeter of defect also. So you can always think about this alpha. This alpha can be 0.10 also, so that you can easily reject the null hypothesis, and you can claim that the difference is there, and then the company will think about that what changes has to be done in manufacturing of those scales. Anyhow, because you are trying to understand, let's the alpha is 0.05, then again you use the same formula and you got the t-test value. It is saying z also, because for the large sample I already have said you that it becomes equal to z-test. But anyhow, you are using t-test because it is more stricter, and whatever result you will get in t-test, it will be applicable for z-test also. So what is the table value? Table value is 1.96 or degrees of freedom 99, because total n is 100, so 100 minus 1 will be the degrees of freedom 99. So for 99 degrees of freedom, the z value is the table value is 1.96. so, and you have obtained t as equal to 2, which is greater than 1.96, so you have to anyhow reject as 0. So you can conclude that the mean differs from 100 centimeter at 5% level, which is marginal. But anyhow, because you are manufacturing, here I am just giving an example that it is manufacturing of a scale or some weight, so you have to think about and you have to see why manufacturing defect is there. So these all cases are of for one sample t-test. Now let us think about the most useful one, the most used one test in the research in the field of social science, education, psychology, and that is whenever you are taking data from humans or from the groups of people, then you are using independent sample t-test, because all the individuals, those who are divided into two groups, suppose boys, girls, private school, government school staff, and then in this type of situation you are using independent sample t-test. I already told you that suppose you want to compare that creativity of students, so creativity of boys and girls, if it is significantly different or not, you have to use independent sample t-test. Suppose you want to see that the average salary of government school teacher is more than the average salary of the private school teacher, you have to use this t-test. So in that cases where the groups are there, two independent groups are there, where the participants are totally different, and that type of cases you are using independent sample t-test. Now here also for small sample, this is the formula: t is equal to mean of first group minus mean of second group divided by SP. SP is pooled standard deviation 1 by n1 plus 1 by n2. N1 and 2 is the sample size of both the groups. So both the groups, these are for small samples. So standard deviation pooled is, this is the formula: n1 minus 1 standard deviation of first group plus n2 minus 1 multiplied by square of standard deviation of the second group divided by n1 plus n2 minus 2. So we will get pooled standard deviation. Then you put it here, you take this as this pooled SD and put it here, and you will get detailed value. Now for the large sample, x1 minus x1 is the mean of the first sample and x2 is the mean of the second sample. In that case, and when the variance is different, you will use Welch formula, and there the value, there the formula is x1 minus x2 divided by s1 square by n1, s2 square by n2 square root. S1 and s2 are the standard deviation of both the groups. Now take the example for a small sample. Group A sample size is 8, group B sample size is 10, which comes under small sample. Means are given, standard deviation is given. So you calculate the pooled variance, pooled standard deviation SP, and you got the value as 5.60 using this formula. Using this formula, you calculate. Now putting this formula in this particular formula, you calculate t value. So first you just try to see the null hypothesis is mu1 is equal to mu2. Both the groups are equal, but alternative is both the groups are not equal. Now calculating t using this formula for small sample, you got the value as 1.89. Now if you compare the degrees of freedom, the degrees of freedom is n1 plus n2 minus 2. So it is 16. 10 plus 8, 18 minus 2, 16. And then you can see the table value. The table value is 2.12. Now just try to see the table value is less than, table value is more than the calculated value. So you will not be able to reject the null hypothesis. So you can say that the null hypothesis is true, and both the groups are same, and mu1 and mu2 are equal. So this is, and this confirms that there is no significant difference. So in that way you are calculating. Now let us take one more example. This first one is also for a small sample, comparing two teaching methods. Suppose two teaching method you are using in group of students. For group 1 there are 12 students and you are using activity based methods, and the students achievement is 85 and standard deviation is 4. Group B you are using, suppose, playway method. The sample size is 10 and the achievement is 80, standard deviation is 5. So hypothesis is both the means are equal, mu1 is equal to mu2 for at the population level, and alternative hypothesis mu1 is not equal to mu2. Population mean of group A is not equal to group B. So now you again calculate pooled standard deviation, and that value is coming as 4.47777. So if we can put this particular value in the t-test formula, the calculated value is 2.608. 2.608 is the calculated value. Now degrees of freedom is again n1 plus n2 minus 2, that is 10 plus 12, 22 minus 2, 20. Now the table value is 2.086. So if you see these two values, the calculated value is more than the table value, so you have to reject the alternative hypothesis, you have to reject the null hypothesis, and you can say that the group differ. The methods are working, one method is superior to the other method in terms of improving the achievement. Now once you are going for the large sample where unequal variance is there, you have to use Welch formula. Now suppose two companies are there, two machines are there, machine 1 and machine 2, and then you are just trying to see, suppose machine 1 50 machines are there. Machine 1 means brand 1, 50 machines are there, and for brand 2 60 machines are there. So for machine 1, suppose this is B printer, let it be printer. Suppose this is HP printer and this is Epson printer, and you have got HP printer in 50 numbers in a company, and you have got Epson printer 60 in a company. Now suppose in an you can say within 15 minutes, with a fixed interval of time, you just try to see how many pages it can print similar type of prints. So for this particular HP machine, suppose you have got, I should not go with the name because otherwise the result will be it can be commercially not good. So let me see that these are two brands of printer. So suppose the first brand is giving 100 pages per hour, and then the second brand of machine is giving 94 pages per hour, and standard deviation is 12 and 15. So here also you will take alpha as 0.05, and then hypothesis is the sample, the population means are equal, and alternative hypothesis they are not equal. Now we will use this formula here, second formula for large sample. So this is x1 mean 1 minus mean 2, and then standard deviation square by n1 standard deviation of n2. So if you calculate this using this formula, so you have got, putting all the values, 100 minus 94, 100 minus 94, then standard deviation is 12 and 15 here, so you put it here, divided by n1 n2. So your calculated value is 2.33. Now degrees of freedom, calculation of degrees of freedom, this is the formula, because now why you are using this degrees of freedom formula, otherwise it is formula is n1 plus n2 minus 2, so it can be 100 plus 94 minus 2, but because variance is not equal, you have to see that what is the working sample on which you are doing the all the calculation. So this formula you have to use, and then the corrected DF is 108. Whenever you will use SPSS also, there also you will find out when the variance condition is not made, the degrees of freedom varies. It is not n1 plus n2 minus 2. It becomes little different. So using this formula only, this particular value you will get. Then the calculated value is 2.33, and then after seeing the value from the table for degrees of freedom 108, the critical value is 1.98. So you just try to see that the calculated value is more than the table value, so you have to reject the null hypothesis, and your decision is that the both machines has got different output, and of course you can say machine 1 has higher output because machine 1 is producing 100 and machine 2 is producing 92. Always you can prefer machine 1 if you are thinking about only about the numbers. So output, maybe the quality and other factors are there, but here you suppose you are concerned about the output level, machine 1 is better than the machine 2. So this is about independent sample t-test. Now let us take the third type of t-test, which is called as pair sample t-test. So whenever the condition is there that you are measuring a particular same group of people 2 times, before and after, suppose pre-test is there and you are giving certain intervention, suppose the teaching method you have used, and then you take the post test and you want to compare if there is a difference between pre and post, and it is significant, then you are using pair sample t-test, and the formula is this one: t equal to difference mean, whatever mean difference is there, that means, and divided by standard deviation of square root of n. So standard deviation of this mean, standard deviation of that particular mean differences, whatever values we have got, that standard deviation, that mean differences, standard deviation is here, and square root of n, whatever total n is there, that you have to divide. So this, suppose this is one example, 6 students are there, before scores are there and after scores are there. So differences are, you can always see difference here is 10, then 3, and like these differences are there. We have forgotten about the sign. So mean is equal to 5.17 because you are mean is this one, and standard deviation is, you have to take all the mean differences, all the differences, and then standard deviation you have to calculate by using the standard deviation formula. So you have got the standard deviation is equal to 2.71. Now if you put this in this particular formula, you have got the t value as 4.65. so if you see the df here is n minus 1, so 6 minus 1 5, the value is 2.57, which is less than the calculated value, so you have to reject the null hypothesis. So you can say that the suppose here treatment one coaching you have used, so coaching has got significant effect on the student's achievement. Now you can take one more example. Suppose here it is also for small sample, for paired sample. It is also used whenever you are going for this type of one-to-one matching, and that cases also it is used, but you are using here many a times it is used for pre and post test condition. So suppose 8 participants measure before and after intervention. Difference is these are only the differences are given here. So two-tailed test is there, alpha is 0.05. So you calculate the mean of that particular differences, and you calculate the standard deviation of that particular differences, and then put in this particular value. The calculated value is 1.732 and the table value is 2.365. So table value is more than the calculated value, so you fail to reject null hypothesis. So you can say no significant mean change detected in this small sample. Again, if it is a large sample, suppose n is 40, sample mean difference is 1.5, already mean difference difference mean has been calculated. Standard deviation of the difference is 4, and you put the value in the formula, the same formula you will use. The calculated value is 2.372, the table value is 2.023, 0.05 level for two-tailed test. DF is 39. So the calculated value is more than the table value, so you have to reject the null hypothesis. The conclusion is significant mean change in the paired measurement for this large sample. So here also you are using the paired sample test, and in case of paired two experiment, whenever you are matching the groups 1 to 1, that cases also you can use this one. It will become but matching the cases should be very much perfectly done, then only you can do this paired sample t-test. Otherwise you can go for independent sample t-test. Now what are the application of t-test? It is used for comparing test score of students taught with two different teaching methods, that we have already seen. In the world of medicine, checking the effectiveness of two different drugs. Psychology, analyzing behavioral changes before and after the intervention, which is one sample paired sample t-test. And in business, evaluating employee productivity before and after, here also paired sample t-test you can take the example. So in this way you are using this one. So let us recapitulate all whatever you have learned in this particular presentation. You have learnt about one sample t-test. So it is used to compare mean with population. Independent sample t-test compare two particular groups. Two independent groups are there, boys and girls, government school, private school. Paired sample compare related samples. If the samples are paired, matched, then in that cases, or before and after condition, we have already seen. But you have to always see the assumption. The assumption for t-test, the sample should be normally distributed. Both the groups should be independent, and then equal variances should be there. Although for unequal variance, you have already seen what you have to do, which formula you have to use. But the ideal condition is normality has to be there, independence has to be there, and then independence means what I mean to say that for the independent sample you are trying to see what is independence. Two groups are there already independent. Before and after condition also, both these readings are independent from each other. So in that sense it should be independent. So for small sample, use t with correct degrees of freedom, check normality for small n. For large sample, it is, you can compare it, you can make it use of Z formula because it is just like a Z distribution. Independent sample, for independent sample, if a small group is there, then you have to use pool variances, and then otherwise you use Welch formula. For paired test, use differences and one sample T on differences, that already we have seen. Always state, and you have to always state the assumptions and degrees of freedom in your explanation. So in that way you are using t-test. So I hope you have understood how to calculate t-test. You go on practicing, taking certain examples from textbooks from different sources and using this formula for one sample t-test, for independent sample t-test, for paired sample t-test. I hope you will be able to solve these problems. You have to learn how to use the tables, and this will help you to understand calculation of t-test values. So thank you. I hope you have learned many things from this particular video. So kindly subscribe to this channel. Thank you. Keep learning, keep growing.